Welcome back to the Sleepy Analyst. If you are here for the first time, you found exactly the right place, at exactly the right moment. Tonight, we are not going up. We are going down. Down past the place where sunlight surrenders. Down past the last warm current. Down past the deepest dive any human has ever made. Down further still, past the creatures that glow in permanent darkness, past mountains taller than anything on the surface of this earth, past rivers that flow silently along the ocean floor, down to a place so remote, so cold, so utterly silent, that more human beings have walked on the surface of the moon than have ever seen it with their own eyes. There is nowhere to be tonight. Nothing to finish. Nothing that needs your attention. Just let the words carry you downward, slowly, like a single snowflake drifting through black water, taking the longest, most peaceful journey imaginable, toward a place that has existed in perfect silence for longer than the human mind can hold. The ocean is not simply water. It is the original home of all life on this planet. It regulates the temperature of every room you have ever slept in. It produces more than half the oxygen in every breath you take. It contains the tallest mountains, the longest rivers, the deepest valleys, and the most extraordinary living things that have ever existed on Earth. And 95% of it has never been seen by human eyes. Not mapped. Not photographed. Not visited. We know more about the surface of Mars than we know about the floor of our own ocean. Tonight, we go there together. This is the story of the deep ocean. The most mysterious, most extraordinary, most unexplored place on the only living planet we have ever known. Let's begin. Stand at the surface of the ocean on a clear day, and the water beneath you looks blue. That blue is not a color the ocean possesses. It is a color the ocean borrows. It is the reflection and scattering of sunlight, that same light breaking apart as it passes through trillions of water molecules, the blue wavelength scattering in every direction until the whole ocean glows with it. But that borrowed light does not last long. In the clearest tropical ocean, sunlight begins to weaken almost immediately. By 10 meters below the surface, the reds have already disappeared. The warm colors, orange, yellow, the pale gold of a late afternoon, they are absorbed first. They do not reach down. By 30 meters, only blue and green remain. By 100 meters, barely any light at all. Oceanographers divide the ocean into zones. Not by geography, but by light. The first zone, from the surface down to 200 meters, is called the sunlight zone. The epipelagic layer. This is the world most people imagine when they think of the ocean. Coral reefs, dolphins, sea turtles, schools of silver fish moving as one organism through shafts of morning light. It is beautiful, and it is almost nothing. 200 meters is roughly the height of a 60-story building. Drop below the roof of that building, and you leave the sunlit world entirely. Below 200 meters begins the twilight zone. The mesopelagic layer. Here, the last traces of light from the surface arrive as a faint, cold, blue-gray glow. Not enough to see by. Not enough to read by. Barely enough to detect with the most sensitive instruments we possess. But enough to cast a shadow. And in the twilight zone, casting a shadow can kill you. The creatures of the twilight zone have evolved over millions of years to manage this precise problem, the danger of being silhouetted against the faint light above them, visible to predators hunting from below. Many of them have solved it the same way. They make their own light. Bioluminescence. It is one of the most extraordinary phenomena in the natural world, and it is not rare. It is not a curiosity found in a few unusual species. In the deep ocean, bioluminescence is the rule, not the exception. Estimates suggest that between 76 and 80% of all deep-sea creatures produce their own light. In some zones, that number approaches 90%. Think about that for a moment. The deep ocean, the largest living space on this planet, is populated almost entirely by creatures that carry their own lanterns. Not borrowed light. Not reflected light. Light built from chemistry. From a reaction between a molecule called luciferin and an enzyme called luciferase, releasing photons of cold, living light in blues and greens and occasional deep reds. In the twilight zone, a creature called the hatchetfish has taken bioluminescence to its logical extreme. Along its belly, it carries rows of tiny light organs called photophores. These organs produce a downward-pointing glow precisely calibrated to match the faint light filtering from above. From below, looking up, the hatchetfish simply disappears. It matches the sky. It becomes invisible by becoming light. This strategy is called counter-illumination. It is one of the most elegant solutions to the problem of survival that evolution has ever produced. And the hatchetfish is not alone. The lanternfish, the bristlemouth, the deep-sea dragonfish, dozens of species have independently discovered the same answer to the same question. How do you hide in a world of faint light? You become the light. Below 1,000 meters, even this faint glow disappears entirely. Here begins the midnight zone. The bathypelagic layer. No sunlight has ever reached here. No sunlight ever will. The pressure is between 100 and 400 times the pressure at the surface. The temperature hovers just above freezing, around 4 degrees Celsius, year-round, without variation. It is permanent, absolute, crushing darkness. And it is full of life. For most of human history, we believed the deep ocean was empty. The logic seemed reasonable. No light. Extreme cold. Crushing pressure. No plants could grow without sunlight, and without plants, what would anything eat? In 1844, the naturalist Edward Forbes declared that below a depth of roughly 500 meters, life simply ceased to exist. He called it the azoic zone, the lifeless zone. And for decades, the scientific community agreed. They were wrong. The first serious challenge came in 1872, when the British naval vessel HMS Challenger set out on the world's first dedicated oceanographic expedition. For 3.5 years, the Challenger sailed the world's oceans, dropping sampling dredges into the deep and hauling them back up. What came up from the depths confounded everyone. Strange, translucent creatures. Things with no eyes. Things with too many eyes. Creatures that seem to belong to no known family, no known order, no known world. The azoic zone did not exist. Life had found a way, as it almost always does, into places we had declared impossible. But the most extraordinary discovery of all did not come until more than a century later. In 1977, a research submarine called Alvin descended to the floor of the Pacific Ocean near the Galapagos Islands. The scientists aboard were searching for hydrothermal vents, cracks in the ocean floor where geothermal heat escapes from the Earth's interior. They found the vents, and clustered around them, in water heated to temperatures far above boiling, in total darkness, under crushing pressure, with no sunlight whatsoever. They found an entire world. Before 1977, science operated on a single assumption about life on Earth. All life depends on the sun. Sunlight drives photosynthesis. Photosynthesis produces oxygen and organic compounds. Those compounds feed everything else. Remove the sun, and the chain breaks. Remove the chain, and life ends. It was not a theory. It was a foundation. The deepest, most unquestioned assumption in all of biology. And then Alvin found the vents. Around those hydrothermal vents, those cracks in the ocean floor where superheated water rich in hydrogen sulfide and other minerals erupts into the freezing deep, the scientists found tube worms 2 meters long, clustered so densely they resembled fields of crimson grain swaying in an invisible current. They found clams the size of dinner plates, shrimp without eyes, crabs with white shells and slow, deliberate movements, mats of pale bacteria coating every surface. A complete ecosystem. A complete food web. Everything feeding everything else. And not a single organism in it had ever required a single photon of sunlight. Instead of photosynthesis, these organisms use chemosynthesis. They harvest energy not from light, but from chemical reactions, the oxidation of hydrogen sulfide and methane and other compounds pouring from the vents. The bacteria at the base of this food chain do not need the sun. They feed on the chemistry of the Earth itself. This discovery did not merely add a footnote to biology. It rewrote its most fundamental chapter. If life can exist without sunlight, if the energy of the Earth's interior can sustain entire ecosystems in permanent darkness, then the question of where else in the universe life might exist suddenly opened wide. Europa, the moon of Jupiter, has a liquid ocean beneath its ice, kept warm by tidal forces. Enceladus, a moon of Saturn, vents water vapor into space from cracks in its frozen surface. The deep ocean of Earth was not just a discovery about this planet. It was an answer to the oldest question our species has ever asked. Are we alone? The hydrothermal vents are not the only place the deep ocean sustains life without sunlight. There are also cold seeps. Where hydrothermal vents are violent, superheated water erupting through the seafloor at temperatures exceeding 400 degrees Celsius, cold seeps are something else entirely. They are places where methane and hydrogen sulfide seep slowly, quietly, almost gently from the ocean floor. The water around them is not hot. It is the same near freezing temperature as the surrounding deep ocean. But it carries the chemical fuel that sustains life. Around cold seeps, similar communities form. Tube worms, clams, mussels, microbial mats. But these communities are even more ancient and more patient than those around the vents. Cold seeps are stable. They do not erupt. They do not shift. Some of them have been seeping for tens of thousands of years without interruption. The tube worms that grow around cold seeps, the species Lamellabrachia luimesi, are among the longest-lived animals on Earth. Not years. Not decades. Centuries. A single tube worm, rooted in the sediment around a cold seep, can live for more than 250 years. Some estimates suggest up to 500 years. They grow slowly, less than a centimeter per year once they reach maturity. Patient beyond anything we can easily imagine. Attached to one spot on the ocean floor, drawing sulfide from the sediment beneath them. Simply existing, quietly, in the dark. While civilizations rose and fell on the surface above them, while empires were built and abandoned, while languages were born and forgotten, a tube worm on the floor of the Gulf of Mexico simply grew. Slowly. Silently. In the dark. There is something very restful about that. In 1987, an event occurred on the floor of the Pacific Ocean that scientists did not discover until years later, when a submarine passed over the site and found something no one had predicted. A whale had died. Not unusual. Whales die. Their bodies sink. And when a creature the size of a city bus sinks to the ocean floor, what follows is one of the most extraordinary ecological events in the natural world. A whale fall. The process unfolds in stages, each one lasting years or decades. In the first stage, lasting months, mobile scavengers arrive, sleeper sharks, hagfish, rat-tail fish, creatures capable of detecting the chemical signal of a decomposing whale from kilometers away. They strip the soft tissue. In a matter of months, a whale that may have weighed 60 tons is reduced to a skeleton. In the second stage, enrichment opportunists move in. Polychaete worms, crustaceans, small invertebrates. They colonize the bones, feeding on the bacteria and organic material coating every surface. Then comes the third stage. And this is where it becomes extraordinary. The bones of a whale are rich in lipids, fats. In the third stage, sulfate-reducing bacteria move deep into the bone itself, consuming those lipids and releasing hydrogen sulfide as a byproduct. And where hydrogen sulfide appears, the same chemosynthetic organisms that colonize hydrothermal vents follow. A single whale skeleton on the ocean floor becomes a temporary hydrothermal vent. A temporary island of chemical energy in the deep desert of the abyssal plain. A community of hundreds of species, some found nowhere else, assembles around it, feeds on it, lives on it. For decades. A single large whale fall can sustain a distinct ecosystem for up to 100 years. Scientists now believe that whale falls may have served, over millions of years of evolution, as stepping stones across the deep ocean. Islands of chemical energy spaced far enough apart to be rare, but frequent enough to allow the slow spread of deep-sea species across the abyssal plain. The whales did not simply live in the ocean. They fed it long after their lives were over. There is a mountain range on this planet that most people have never heard of. It is the longest mountain range on Earth. It stretches for more than 65,000 kilometers, winding through every ocean, crossing every hemisphere, connecting the Arctic to the Antarctic in a single continuous chain of peaks and ridges. It is called the mid-ocean ridge. From the surface, it is completely invisible. It lies on the ocean floor, hidden beneath kilometers of water, its peaks rising between 2 and 3 kilometers above the abyssal plain. In some places, its summits come within a few hundred meters of the ocean's surface. In others, it lies buried under 4 kilometers of water, unknown and unvisited. The mid-ocean ridge exists because the Earth is alive. Beneath the ocean floor, the tectonic plates that carry the continents and the ocean basins are in constant, imperceptibly slow motion. Where two plates pull apart, which happens along the crest of the mid-ocean ridge, magma from the Earth's mantle rises to fill the gap. It cools. It solidifies. It becomes new ocean floor. At this very moment, the ocean floor beneath the Atlantic is growing. The Americas are moving away from Europe and Africa. Not fast. Not in any way you could ever feel. About 2 to 3 centimeters per year, roughly the speed at which your fingernails grow. But over millions of years, at that gentle pace, the Atlantic Ocean has grown from nothing to its current width of more than 7,000 kilometers. The ocean itself is young, constantly renewed. The oldest ocean floor on Earth is only about 340 million years old, a fraction of the Earth's 4.5 billion year history. The oldest continental rock is more than 4 billion years old. The ocean floors are recycled, carried away at subduction zones, pulled back into the mantle, melted, remade. The ocean is not permanent. It is a process. It has always been a process, forever being made and unmade, growing and shrinking, changing shape over timescales our minds cannot truly hold. Below the mountains of the mid-ocean ridge, beyond the hydrothermal vent fields that line its crest, stretches the abyssal plain, the largest habitat on Earth. The abyssal plain covers more than 50% of the planet's surface. It lies at depths between 3,000 and 6,000 meters. It is dark. It is cold. The pressure at 4,000 meters is 400 times the pressure at sea level. To most people, the word plain suggests emptiness. Featureless. Barren. The abyssal plain is neither. The sediment on the abyssal plain is one of the most extraordinary substances on Earth. It accumulates almost unimaginably slowly, at a rate of about 1 centimeter per 1,000 years in some regions. The sediment you would hold in your hand after a dive to the abyssal plain might represent 100,000 years of slow, patient accumulation. Dust from distant continents. The microscopic shells of dead organisms that sank from the surface over millennia. Tiny iron-manganese spheres that grow 1 millimeter every million years. Nodules. The abyssal plain is scattered with manganese nodules, potato-shaped rocks that grow so slowly they barely seem to move at all. A nodule the size of your fist may have taken 10 million years to form. They are rich in cobalt, nickel, copper, and rare earth minerals. Minerals that the modern world hungers for batteries, for electronics, for the green energy transition. And the deep-sea mining industry has its eyes on them. What would be lost if we mined them is not yet fully understood. The abyssal communities that have evolved over millions of years around these nodules, the specialist organisms that live on their surfaces, the slow-moving sea cucumbers and brittle stars and bacteria that have adapted to this specific, ancient substrate, they recover slowly, if at all. A habitat destroyed in weeks. Rebuilt over millions of years. the abyssal plane keeps its secrets well, and the cost of taking them from it may be higher than we yet know. If you were to drain the world's oceans, every drop of seawater removed, every basin exposed, you would find something that no map has ever fully shown. Mountains, canyons, plains, valleys, rivers, lakes, an entire world hidden beneath the water. A world more topographically varied than anything on the dry continents. The Mariana Trench is the most famous of the ocean's hidden features. Located in the western Pacific Ocean, east of the Mariana Islands, it is the deepest place on Earth. Its deepest point, a small depression called Challenger Deep, lies approximately 11,000 meters below the surface. Nearly 11 kilometers. To put that in perspective, if you placed Mount Everest at the bottom of Challenger Deep, its summit would still be more than 2 kilometers underwater. The pressure at Challenger Deep is approximately 1,096 times the atmospheric pressure at sea level. Every square centimeter of any object at that depth bears a weight of more than 1,000 kilograms. A human body, unprotected, would not be crushed instantly. The body contains fluids, and fluids transmit pressure. What would happen is stranger. The nitrogen in the tissues would be forced into solution, the air spaces would collapse, the bones would remain intact while the soft tissue changed in ways we would prefer not to contemplate. And yet, life is there. At the deepest point on Earth, in water under a pressure no engineering has ever fully replicated, in absolute darkness, in near freezing cold. Microbes. Amphipods, small crustaceans resembling shrimp, translucent and ghostly. A snailfish, pale and soft, filmed drifting through the blackness at more than 8,000 meters, the deepest fish ever recorded. Life. Always, impossibly, beautifully, stubbornly, life. The deep ocean has a sound. Not the crashing of waves. Not the calls of whales near the surface. Something else. Something that travels further than almost anything else on this planet. Water conducts sound much more efficiently than air. Sound moves through seawater at approximately 1,500 meters per second, roughly 4 times faster than through air. And at a specific depth in every ocean, varying by location, but typically between 600 and 900 meters, a remarkable phenomenon occurs. At this depth, the combined effect of temperature and pressure creates a channel. A layer in which the speed of sound reaches a local minimum. Sound waves entering this layer from above or below bend back toward it, trapped. Channeled. Unable to escape. This layer is called the SOFAR channel, the sound fixing and ranging channel. Sound that enters the SOFAR channel does not dissipate outward in 3 dimensions as it would in open air. It is trapped in 2 dimensions, spreading outward in a ring but unable to escape upward or downward. The result is extraordinary. A sound made in the SOFAR channel can travel thousands of kilometers. In some conditions, it can travel entirely across an ocean. During the Second World War, the military discovered this channel and used it to locate downed pilots. A pilot who parachuted into the ocean would set off a small explosive charge at the right depth. The sound would travel through the SOFAR channel to listening stations on opposite sides of the ocean, and from the timing of its arrival, the pilot's position could be triangulated. Sound as a lifeline, carried by the sea itself. Fin whales use the SOFAR channel to communicate across entire ocean basins. Their low-frequency calls, so low-pitched they are below the range of human hearing, travel thousands of kilometers through the channel, reaching other whales on the far side of the ocean. A fin whale in the North Atlantic can be heard, in the right conditions, by a fin whale in the North Pacific. The ocean has always been full of these invisible conversations, long before we knew how to listen. In 1997, the National Oceanic and Atmospheric Administration was monitoring the SOFAR channel with a network of underwater hydrophones, sensitive microphones anchored in the deep ocean. These hydrophones were originally installed during the Cold War to listen for Soviet submarines. After the Cold War ended, they were repurposed for scientific monitoring. On the 18th of May, 1997, the hydrophones detected something. A sound. It was extraordinarily powerful. One of the most powerful sounds ever recorded in the ocean. It lasted approximately 1 minute, rising in frequency at the start, a quality that reminded the scientists who first heard it of something biological. Something alive. They named it the bloop. The bloop attracted enormous public attention. Headlines speculated about giant unknown creatures. Sea monsters. The kinds of things that older sailors had always insisted lived in the deep. The scientists were more cautious. For years, the bloop remained unexplained. A genuine mystery from the bottom of the ocean. In 2012, after 15 years of analysis, a likely explanation emerged. The bloop's characteristics, its frequency profile, its duration, the way it moved, matched the acoustic signature of a specific and well-understood phenomenon. Icequakes. When large icebergs fracture and carve on the ocean floor or against underwater shelves in the Antarctic, they produce sounds of extraordinary power. Low frequency, rising pitch, traveling vast distances through the SOFAR channel. The bloop was almost certainly the sound of ice breaking. Not a monster. Not an unknown creature. Just the ancient sound of the Earth's ice doing what it has always done, cracking, shifting, falling, over and over in the dark. And yet, the ocean is large, and most of it has never been listened to. There are lakes in the deep ocean. Not metaphorical lakes. Actual lakes, bodies of water sitting on the ocean floor, with distinct surfaces, visible shorelines, and waves. They are called brine pools. In certain parts of the ocean floor, particularly the Gulf of Mexico and the Red Sea, ancient salt deposits lie buried beneath the sediment. When seawater percolates down through cracks and dissolves these deposits, it becomes saturated with salt. Hypersaline. 3 to 8 times saltier than normal seawater. This hypersaline brine is denser than the seawater above it. It sinks. It pools. It collects in depressions on the seafloor. And there it sits. A brine pool has a visible surface, a sharp boundary between the hypersaline brine and the normal seawater above it. If you watched a remotely operated vehicle descend into one, you would see it cross a surface. Ripples would form. The water below would be visibly different, shimmering slightly, like a mirage. And it would be lethal. To most deep-sea creatures, brine pools are death. The salt concentration is so extreme that most organisms die almost instantly on contact. The brine pools are sometimes called the jacuzzis of despair by the scientists who study them, warm, inviting looking, and immediately fatal. But not to everything. Around the edges of brine pools, in the zone where hypersaline brine meets normal seawater, microbial communities have established themselves, adapted to the chemical chaos of the boundary, living in conditions that would kill almost anything else. And in a handful of brine pools, scientists have found something even stranger. Mussels. Living on the shoreline of an underwater lake, feeding on the methane-consuming bacteria that colonize the pool's edge. Mussels on the shore of a lake on the floor of the ocean. There are worlds inside worlds down there. The deep ocean is home to some of the most extraordinary living things on this planet. Not extraordinary in the way we usually mean the word, not large, not colorful, not charismatic in any way that makes us want to hang their pictures on walls. Extraordinary in the way that true strangeness is extraordinary. In the way that forces you to question what a living thing is allowed to be. The barrel-eye fish. It lives in the twilight zone, between 200 and 1,000 meters. It is small, rarely more than 15 centimeters long. Translucent. Its internal organs are faintly visible through its body wall. But its eyes. The barrel-eye fish has two large, cylindrical eyes that point directly upward through a transparent dome of fluid on top of its head. The eyes are a vivid, luminous green, designed to detect the faint silhouettes of prey against the dim light filtering from above. For decades, scientists studying preserved specimens were confused. The eyes seemed fixed, permanently pointing upward. How did the fish see anything in front of it? When living specimens were finally observed in the deep, the answer revealed itself. The eyes rotate. The barrel-eye can swivel its eyes forward, through the transparent dome, to look directly ahead. Or upward, to hunt by silhouette. Or anywhere in between. A fish with rotating eyes in a transparent fluid dome on the top of its head, hunting in permanent twilight 200 meters below the surface of the ocean. No human imagination would have invented it. Evolution had millions of years and no preconceptions. The vampire squid. Despite its name, it is neither a squid nor an octopus. It occupies its own order, Vampiromorphidae, entirely alone. The last surviving species of an ancient lineage. It lives in the oxygen minimum zone, a layer of the ocean where oxygen levels are so low that most creatures cannot survive. The vampire squid can, because it has evolved hemocyan-enriched blood that extracts oxygen with extraordinary efficiency. It is small, about 30 centimeters long. Dark reddish-brown. Its body is covered in light-producing organs. Between its arms, a cloak of webbing connects them, forming a cape it can pull over itself to disappear, inverting its body, pulling its arms over its mantle, presenting nothing but the textured, dark outer surface to any predator. The vampire squid does not hunt. It is one of the very few deep-sea cephalopods that has abandoned predation entirely. Instead, it feeds on marine snow. Marine snow is one of the most beautiful things in the deep ocean, and one of the most important. It is not snow. It is a continuous, gentle rain of organic particles from the surface ocean, dead plankton, fecal pellets, fragments of larger organisms, clumps of bacteria held together in mucus strings. It falls slowly, continuously, through every layer of the ocean, from the sunlit surface all the way to the abyssal plain. It is the primary food supply of the deep ocean. The mechanism by which energy fixed at the surface by photosynthesis reaches the lightless depths kilometers below. And the vampire squid drifts through it, trailing two long filaments behind its body, collecting particles one by one from the slow dark rain. Patient, silent, ancient. While everything else in the deep ocean hunts and is hunted, the last of its kind simply drifts, feeding on snow, alone in the oxygen minimum zone where nothing else can follow. The giant squid remained a legend for most of human history. Sailors reported it for centuries, the kraken of Norse mythology, the tentacled monster that dragged ships to the bottom. Science was skeptical. Legends are not evidence. But the sperm whales told a different story. Sperm whales feed in the deep ocean, diving to depths of more than 2 kilometers in pursuit of prey. When their stomach contents were examined, scientists found the beaks of giant squid, the only part that does not digest easily. And on the skin of sperm whales, circular scars, the sucker marks of squid arms, measured in some cases at more than 30 centimeters in diameter. A squid with suckers 30 centimeters across would be an animal of extraordinary size. The first photograph of a living giant squid in its natural habitat was not taken until 2004. The first video footage not until 2012. For all but the last 20 years of human history, one of the largest invertebrates on Earth existed only as washed-up corpses, whale stomach contents, and the nightmares of sailors. Adult giant squid reach lengths of up to 13 meters. Their eyes, the largest eyes of any animal on Earth, can measure 30 centimeters in diameter. Eyes that size evolved, scientists believe, specifically to detect the bioluminescent flashes produced when a sperm whale disturbs the water on its approach, giving the squid a fraction of a second's warning to flee. A 30-centimeter eye to see the light of a predator coming through the dark. The deep ocean is not empty. It is full of things we are only just beginning to understand. We have explored less than 5% of the ocean. Not 5% of the deep ocean. 5% of the whole ocean. The ocean floor is less well mapped than the surface of Mars. Less well mapped than the near side of the Moon. There are regions of the Pacific and Indian Oceans where the seafloor has never been directly observed. Never sampled. Never photographed. Scientists estimate that there are between 700,000 and 1 million species living in the deep ocean. We have formally described and named approximately 250,000 of them. That means that somewhere between 750,000 species live in the deep ocean that no human being has ever seen. Named. Studied. Even detected. Creatures that have evolved over hundreds of millions of years in complete isolation from the surface world. Creatures that have developed solutions to the problems of darkness and pressure and cold that we cannot yet imagine. Creatures that may carry chemistry we have never encountered. Biological processes that operate on principles we do not yet know. Every deep-sea expedition returns with something new. Not occasionally. Every time. A new species of fish. A new bacterial chemistry. A new structure in the sediment. A behavior no one predicted. A sound no one has explained. The ocean holds things that have been waiting, patiently, in the dark, for longer than our species has existed. It does not offer them easily. We began tonight at the surface, at that thin, luminous boundary where the borrowed blue of sunlight meets the open air. We descended together through the twilight zone, where creatures carry their own light. Through the midnight zone, where pressure builds and temperature drops and the darkness becomes absolute. We drifted past hydrothermal vents where entire ecosystems live on the chemistry of the Earth itself, untouched by any ray of sunlight. Past cold seeps where tube worms grow for 500 years in patient silence. Past whale falls where a single enormous body sustains a community for a century. We crossed the abyssal plain, the largest habitat on Earth, past ancient nodules that took 10 million years to form. Down into the deepest trenches, where snailfish drift through the blackness at 11 kilometers below the surface. We listened to the SOFAR channel carrying sounds across entire ocean basins. We found lakes on the ocean floor and rivers running silently below the sea. We met creatures that evolution built in the dark with no reference to anything we know above. And we did not see most of it. 95% of the ocean remains unseen. It is still there, right now, as you rest. The deep ocean does not stop for night. It does not change with the hours. 3 kilometers below the surface of the Pacific Ocean, in a darkness that has been absolute since before the first fish evolved to swim in it, the hydrothermal vents are still venting. The tube worms are still growing. The marine snow is still falling. The barrel eye is still rotating its luminous eyes, hunting in the twilight. The vampire squid is still drifting, trailing its filaments through the slow dark rain. Somewhere in the mid-Atlantic, a fin whale is singing, a sound so low you would not hear it, traveling through the SOFAR channel toward an ocean away. And somewhere on the abyssal plain, in a place no human has ever visited and may never visit, something is living that no human has ever seen. This planet is not fully known. It may never be. And somehow, that is not frightening. It is the most extraordinary comfort imaginable. That the world is larger than we know. That mystery still exists at extraordinary depth. That the ocean keeps its secrets so well that entire worlds can live inside it, undiscovered, for millions of years. You are resting on a planet that is mostly water. Beneath that water is a world as vast and varied and full of life as anything on the surface. It has been there for billions of years. It will be there long after every city built by human hands has returned to dust. And tonight, it is simply there. Beneath you. Patient and dark and full of wonders. Let that be the last thought that carries you. Thank you for spending tonight here on the Sleepy Analyst. Sleep well. Dream softly. Good night.